This is the Earth Science Classroom. Welcome back. This is the erosion, gravity, and mass wasting part 2 video. And as you can see, got some awesome pictures here of some various types of rock falls and landslides and rock debris avalanches and different slope angles. And this is basically what's on, is how gravity creates this kind of movement on a gradient or slope of this massive rock or soil or regolith moving down slope with gravity. So that's pretty much what was in part 1. And then today with part 2, we're going to look at the 3 factors that control instability that can work with the triggers that were in part 1, things like water, the amount of water in the soil and the porosity, the oversteepened, the degree of gradient of the slope can impact it, and also earthquakes and other large movement of shaking that can dislodge rock. And then we look at the angle of repose, and what that is in relation to the stability, and if a slope is going to fail or not fail. And then look at the different types of mass wasting and mass movement based on the 3 factors that control instability. So a quick review from part 1. Gravity is consistent. It's 9.8 meters per second squared. Acceleration, which acts upon the surface material evenly, pretty much around the whole world. And slope and gradient, which is basically where the ground is not flat, will increase the shear force against normal force, and thus, based on the slope strength, will send material down slope, again under the force of gravity. Mass wasting is a general term for most of these movements, but generally the fast and sudden types, whereas mass movement is more of a generic term, which also is landslide, a generic term. The material moved is usually soil or regolith or bedrock. Regolith is that unconsolidated material that sits above the bedrock. Usually it's part of an outcrop that's not part of soil. So the unconsolidated versus consolidated material, that is based on the looseness, the fragments or one piece, the friction level, and whether it's going to be moving. So unconsolidated is the fragments and loose material, occasionally called incoherent material, and then consolidated is that solid piece that's called coherent, that moves as a whole. Alright, so now on to the 3 factors. Now on to part 2. So the 3 factors that will determine the instability and a slope failure. So looking at a slope, whether this material here that could be weathered with joints or bedding planes or some sort of like instability due to the elements or various triggers is going to move down slope by the force of gravity. Okay, so Fg. Alright, and you've got the force, shear force, and normal force like this. So looking at the potential for failure. So failure means that the rock will be moving down slope at a certain distance, at a certain velocity, and the first thing that really is a defining factor is the type of material. So the material type could be an assortment of sizes, from the small grains of sand and quartz and minerals to large boulders and very large rocks. So the size will basically dictate based on the mass and also the friction. Okay, and this will again look at the angle or the gradient, which will also add into play with the size of material. Then you also have the composition, which is again the likelihood for further weathering as the rock would be exposed, or initial weathering, and then based on the composition that would dictate if it's broken down further, so the surface area would increase, and thus again come back to changing the size of the material, which would dictate whether it is going to fail or not. The next one is going to be the shape. So the shape would be either an angular rock or more of a rounded, smoother rock. The angular rock actually would be more stable in most situations, whereas the more rounded, softer, smoother rock would be unstable and with a increased chance of failure with this one. Then, in terms of both shape and size and composition, we can talk about the actual, is it going to be unconsolidated, which would be incoherent? Would it be consolidated, which another term for that is coherent? Now, easy way, unconsolidated, that's our loose fragments, and consolidated is our more solid, larger, more as a whole piece of material. Okay, so that again would come down to the composition, the size, shape, and the likelihood of failure. With a more unconsolidated material or bits of fragments and with various triggers, that would be more likely to fail, whereas the consolidated, larger, more as a whole piece of material, that would take more to make it fail. Just to conclude in terms of the size, we can look at different categories of size in terms of the bedrock or the soil or the regolith. And we're looking at obviously coarse-grained and versus fine-grained. The fine-grained would be more likely to be unconsolidated, and the coarser grain would, again, well, either one could be unconsolidated, but there's more chance of failure with perhaps a fine-grained based on the ease and size of movement versus a coarser grain, maybe it's a larger mass and would take more triggers and maybe a steeper angle to go for failure. Next one is the type of motion. This is one of the factors, one of the three factors that can determine instability and slope failure. So type of motion. Motion means how it's going to move. So there could be the style or just the speed, or mostly the way it's going to move. So this obviously is based on a lot of the material types that I discussed in the first factor. But the three main types of motion. So the first one, I'll just do A as the first one. A. This would be just a basic fall. So you've got usually some sort of really steep or even vertical, in some cases, vertical gradient, and the relief is obviously the shape of the land, a certain shape, and it can include rocks of various sizes actually going under free fall, and even a topple. Now a topple is where you have the side of the rock and it just like has a joint that goes down vertically and just moves as a whole like this, like a tree that's fallen down, just a toppling effect, rather than just a single rock falling down or collection of rocks as a single unit, just kind of like, you know, how a tree falls, and you know, a topple would be that situation with the rock moving as a whole, based on the degree of gradient. And once the material falls, generally it's unconsolidated, and this material is going to accumulate at the bottom of wherever the material stops falling. So this accumulation usually occurs in a fan shape or a pyramid kind of shape, and this is called talus, or in some cases it's called scree. And it's how, like, if you have like a little cliff right here and there's rocks falling off, it would accumulate down here, and this accumulation, this kind of like slope of accumulation of material that's fallen down over time, would be called talus or scree. Before we discussed the second motion type, don't forget this is all to do with when the slope fails. So slope failure, obviously you need it to fail in order to have the motion down slope. Okay, and it's one of the factors that would determine this. So the next one, but B, right here, B, is a slide. Now this is probably the most famous because landslide is a very common word, and it's in movies, it's in books, it's in documentaries, it's in textbooks. It's a very common word that most children from a young age would get to know. Maybe not the details and the geology of it, but definitely understand what a landslide is and can picture it maybe from a cartoon or a movie or a book they've read. So landslide is that general term. But slide is the movement. Obviously land would be the material. But this is a very generic word. So there's various types of slides that can happen on the slope. These are usually coherent material that's going to move as one or as a whole, and could be generally sudden, but again based on the environment, the different triggers that may occur in that location to cause the slope failure. So the first type is called a slump. Kind of slumps down. So imagine yourself in a nice comfy couch. You're going to slump down into it. Now this usually involves rotation of the material. So it's called rotational. And this can happen through oversteepening or oversteepened gradients, and can also be obviously curved in the motion of the slump. You can have a block slide, more singular, or you could have more multiple, which is called a rock slide. More multiple accumulations of material falling down again as a whole, but blocky is, I guess, larger, and rocky will be more, let's say, unconsolidated than blocky or block slide. And then you've got the debris avalanche, which would dictate the speed. Avalanche is very quick, very fast movements of debris and material. Again, this would dictate perhaps the certain size and composition. Also, block and rock slide is more what's called translational. Translational would dictate basically moving from one place to another, but it's kind of a start and stop. So it starts at one point and quickly moves as a whole, and then ends at a particular point, a sudden end. So translational, like you're going from English to French, you would translate one word or a sentence. It's more like start and stop, whereas perhaps a slump could be more of a continuous action. Okay, and debris avalanche is very, very quick. All right, the third factor, the last one, this is called a flow. So we already discussed fall and slide. Now this one is flow. Now flow would be a mixture, or the material, again composition, the material would be a mixture of air and water in between, obviously, the rocky material, which could be either soil, regolith, or bedrock. So with this liquid component, or the addition of air and water, you might change obviously the viscosity and obviously the velocity and how it behaves. Because the more liquid component is going to behave differently, especially under gravity and different slope types, compared to a rock fall or a rock slide. It'll be much more of a changing, more fluctuating character than a discrete rockfall or slump. There are two main kind of characteristics or categories. There is a slurry flow, which has the most amount of water, or a percent of water in the flow, which is 20 to 40% of it is going to be water based. And then you've got the lower amount, which is called granular, a granular flow, which is 0%. Obviously, 0 would be just a regular, a slide perhaps, up to a maximum of 20% water capacity. And again, this would dictate the speed and the viscosity of the materials that are flowing down the hillside. Now, anything above 40% will just be classified as a stream, a fluvial system that would carry a certain load, either suspended or bed load of material. So anything above 40% would just be called a stream. It's too much water to be called a flow. It has to be called then just a stream. So I'm going to put an S right here and a G right here for abbreviation. So when I go through the different types, I'll link up if it's a slurry flow or granular flow. So the first one is a debris flow. It can also be a lahar if it's more of a volcanic material origin, or genesis is lahar. The debris flow, this is going to be a slurry flow, so more water inside of it. Then you have the earth flow, which again would be granular, so it's less water capacity. You can also have what's called a mud flow, which again would dictate the composition, and again similar to a lahar, but a lahar is a volcanic mud flow. Okay, we have a debris avalanche, again dictating the speed and the material at which is moving so fast is going down the mountain. And the last one we can have is a creep, which again is classic, but this is granular. And sorry, the debris flow again is also granular. So the creep is extremely slow, like millimeters per year. So over a time lapse of, let's say, 10 years or so, you'd see that movement, and it's like a gradual movement down the hill due to freeze thawing, due to wet and dry seasons and precip and water table. So it's very slow, and you might see a tree like, leaning over that it shouldn't be leaning over. This is a tree. I am also a fantastic artist, as you can imagine. Or maybe a fence or a hedgerow that is leaning. That was initially put in vertically, but over the course of many years it started to lean over because of the creep. And this depends on the climate, the soil type, and obviously the gradient. And there's one more to discuss, especially with soil in mind. Solar fluxion, which is just basically soil movement with a lot of water that has been percolated and infiltrated into that water. And again, it's very slow, and this would be actually a slurry flow. So there's a large amount of water in the soil, and it slowly moves down with the gradient. So imagine you have a bunch of sand in a bottle, and you pour the sand out. And the sand falls with gravity, obviously, and let's say there's a countertop or a surface here, and the sand is going to fall down and hit and start to accumulate on the surface. What's going to happen is it will take a certain shape, and it will create this kind of like pyramid, and it will be shaped like this as the sand kind of like drops and accumulates and deposits. And this triangle, if I just enlarge it right now, this triangle, okay, here's my surface, and here is my unconsolidated sand material, okay? This right here, this angle right here is called the angle of repose. Now, there's a certain angle which would, every material has a certain angle of repose, and it's based on the size and shape and composition. Now that material, the angle, the average is 35 degrees. Now what that means is that if there's a slope gradient of, the angle's 35 degrees according to the surface, then we have stability. There will be no failure. And as long as that maintains 35%, you pour more sand, it will accumulate here and keep the same angle. Now, if it gets less, let's say you pour more, and it gets a bit wider, and the angle gets less than 35, obviously it's incredibly more stable. However, if the angle is increased to above 35 degrees, then you will have instability and a greater chance, increased chance of failure with a certain kind of motion, a certain kind of speed, and a certain kind of material would dictate the mass wasting method that will come down the slope. So the angle of repose is very important to consider when looking at gravity and erosion. So in addition, you can link up the angle of repose to obviously any kind of like over steepening over steepened slope. You can look at the water, the addition of water, the addition of any kind of like earthquakes and large triggers. So all these would be the triggers. And you can also link it up to the 3 factors as well, which would be the material type, the type of motion that's going to happen on that slope, failure or no failure, and obviously the speed or the type of flow, okay, the speed of flow and type of flow that you'll get on that thing. So it's a nice little package to like include angular repose in all of those calculations when you're discussing gravity and mass wasted. This is the Earth Science Classroom. Thank you for watching. I hope you enjoyed the content. Check out more videos on our channel, and don't forget to subscribe. Thank you again.